Hi, good morning, my dear students. Let's continue the topic called error analysis, right? What is our topic? The topic of today's session is error analysis. In this error analysis, we will be starting our discussion with what is an error. Then we'll move to the topic called what exactly called a true value or an actual value. Each and every thing is very important in understanding the further topics. The next we'll start with types of errors. What is that? Types of error. So in these types of error, we'll start with absolute error. What is that? Absolute error. Then the name of the topic is relative error. After that, percentage error. The topic name is what? Percentage error. So these are all the things we'll be discussing along with numericals. Alright. So there is not much importance of these concepts in a NEET exam, even PUC exam, for JEE exam. There's no importance for this. But as it is given in the syllabus, we'll be discussing. There will be a little importance in the further topics of these definitions and few basic numericals. It will help in the further topics, that's it. Directly there is no importance, for sure. Alright, but still, let's discuss each and every part. What is an error? Already I have told you, error is the difference between the measured value and the true value. Error is what? The difference between the measured value and the true value. So to understand the concept of error, we should understand the true value or actual value first. What is the true value and actual value? Let me write here. Carefully see. I have measured, as we have discussed in the last class, I had measured the length of this object. Okay. The length of this object, first I have measured and got, carefully see, first measurement, let me take it is an individual measurement. I'm just naming it as x1. So I've got this x1 as a 14.6 centimeters. Alright. Now the second measurement I have got x2 as 14.5 centimeters. The third measurement, so I have got, which is x3 is 14.6 centimeters. And the fourth measurement will be x4, which is 14.3 centimeters. Alright, carefully see. So many individual measurements I have made and I have got the length of this object. Right? To find the true value from this, when you start your experimentation and your laboratory sessions in 11th standard, you will understand how to take the true value or the actual value, right? It is so simple. The true value or an actual value is the mean. Mean of what? Mean or average of all these individual measurements. Alright? So I am writing here, your true value will be equal to the mean value of all these individual measurements. I can also say the arithmetic mean of the large number of individual measurements is called the true value. Large number of individual measurements to x1 plus x2 plus x3 plus x4 so on. You will be measuring till n. Depends on the availability of time and the experiment. So divided by n. So that's it. So this is n. N is what? How many measurements we have taken here? For example, 1, 2, 3, 4. x1 plus x2 plus x3 plus x4 divided by 4. So this is the mean value. Mean value is arithmetic mean. That's called the true value. This is also called as an actual value. Alright? On actual value. No confusions at all. Okay, my dear students. Now you know the true value and actual value. Let's discuss about the error now. It's so simple. Error is the difference between a measured value and the true value. Measured value and the true value. Like we discussed in the last class, if your measured value is more, then the error will be positive. If the true value is more comparatively, the error will be negative, right? So this error may be positive or negative. No confusions. Depends on if this measured value is more than true value, you get error is positive. If your measured value is less than true value, you get error is negative. No confusions at all. My dear students, I hope you are understanding it very well. Now, let's discuss further. You know about first two things now. Let's discuss about types of error. Absolute error. So simple. This absolute error is denoted with a symbol, carefully see, mod delta x. X is an individual measurement. Delta is called change or difference. Mod is modulus. See here, let me write here somewhere. So this is the symbol called modulus. What is that? Modulus. No confusions. So what this modulus you do, you know? Whatever the quantity you keep inside this modulus, so we call this in a short form mod, right? So for example, modulus of minus x if you write, so that is nothing but plus x. Whatever the negative symbol is inside the modulus, so that will come out as a positive. We need to consider that as a positive, right? For example, if you take a minus 2 which is equal to plus 2. When you write minus 2 inside the modulus, it is nothing but a plus 2. Modulus means a magnitude of the value. We need not to consider the sign. Modulus means the magnitude of a particular measurement or a value we need to take. I hope you understand. Now, absolute error is denoted with symbol, right? What is this symbol? Look at here carefully. Absolute error will be there for an individual, carefully see, for an individual measurement. Absolute error will be there for an individual measurement. That means I can write mod delta x1 means in the first measured value, in the first measurement also there will be an absolute error. So what is this absolute error? You see here. So mod, it is the difference between first individual value minus x mean, minus the true value. No need to by heart. Absolute error is the difference between individual measurement and the mean value. Individual measurement and the mean value, right? So once again, delta x2, that is the absolute error will be present in every individual measurement. That is why in the second individual measurement, absolute error will be equal to x2 minus x mean. In the third individual measurement, there is an absolute error, x3 minus x mean. In the fourth individual measurement, the absolute error will be mod delta x4, which is equal to x4 minus x mean. Alright. Clear? Now, there is a mean absolute error. What is that? The concept is called the mean absolute error. Carefully see. Mean absolute error. Mean absolute error is denoted with the symbol mod delta x mean. Alright, what is that? Mod delta x mean. It's so simple. From this you can write the mean value, right? So delta x mod delta x mean is equal to, what is that? Delta x1 plus delta x2 plus so on till delta xn divided by n. So this is called, what is it called? A mean absolute error. Do you understand, my dear students? So simple. Mean value of all absolute errors is called a mean absolute error. What is it called? Mean absolute error. Alright? Simple. Delta x1 mod delta x1 plus mod delta x2 plus mod delta x3 plus mod delta x4 divided by 4. If you have 4 individual measurements. If you have n individual measurements, it will be delta x1 plus a delta x2 plus delta x3 so on delta xn divided by n. That's what the mean absolute error. Now, the most important part of the error analysis, the heart, you can say the heart of the error analysis, I am going to tell you here. Any quantity, listen, any quantity can be written in this way, including the errors. Any physical quantity, that may be the mass, length, time, velocity, acceleration, force, torque, work, energy, power, resistor, anything you can write in this form. Any quantity of the physics, any physical quantity in the physics can be expressed according to the errors in this way. Listen carefully. The quantity, imagine the quantity is x. Quantity is what? X, the final value of x, which is equal to x mean plus or minus delta x mean. What is that? X mean plus or minus delta x mean. Okay. Any quantity. What is x? Final value of x, I am writing here. The x is any quantity, its final value as per its errors can be written in this way. X is equal to x mean plus or minus delta x mean. You know the delta x mean? Mean absolute error, and this is true value. Mean absolute error, and this is true value. Remember, any physical quantity, its final value can be expressed in terms of errors in this way. X is equal to x mean plus or minus delta x mean. Okay. So when you want the maximum error available in that, that will be plus delta x mean you need to consider. When there is a minimum error contained in a physical quantity, so you need to consider minus x mean minus delta x mean, minimum. Okay. So most of the times we take the maximum error present in the quantity will be x mean plus delta x mean. Remember, again and again you will get any quantity can be represented like this. For example, a quantity called y. So if the quantity is y, you can write this y is equal to y mean plus or minus delta y mean. It's so simple. Okay. Clear? Now, the next topic is the relative error. It is so simple. It is so simple. Relative error is so simple. Relative error is, let's take this one here. First, delta x mean. Relative error is the ratio of mean absolute error by true value. So simple. What is that? Mean absolute error by true value. Okay. Mean absolute error by true value. That is called the relative error. So tell me whether the relative error will have units or not. It's impossible because both the numerator and denominator are same. Relative error will not have any units because both numerator and denominator will have the same physical quantity. Okay, clear? So this is the relative error. So now the last type of error is the percentage error. Simple. When this relative error is multiplied with 100. See, there is a relative error here. It is multiplied with 100. This we can say a percentage error. When the relative error is multiplied with 100, we can say this is the percentage error. In one slide, complete concept of errors is there. Again, I am telling you, nowhere you will learn this kind of analysis of errors. Simply, most of the students will try to skip it because it's not important. But important area, I will tell you, important area of the errors. This is the basics. Okay, we have not started the level, like the middle level or the advanced level of the error analysis. We have just started the basics, and in this basic, the most important part you should understand is this one. Any physical quantity, the final value can be expressed in terms of errors in this way. Final value is equal to mean value plus or minus delta x mean value. In a physical quantity, for example, see, I have written already. In a physical quantity, for example, this physical quantity may be a force. This force is equal to the mean value of the final value. How you get it? Mean value of the force plus or minus delta y mean value of the force. You know how to find y mean. See, sum of individual measurements by number, total number of measurements. Finished. Delta y mean also you can find out. How? See, delta y mean is equal to delta x1 plus delta x2 plus delta x3 so on. The question will be asked like this. Absolute error. Individual absolute error or the mean absolute error, finally it will be positive because there is a modulus is present. Finally it will be positive. Okay, alright. Let's start with a basic numerical, then we'll move to the middle level concepts of error analysis. Alright, my dear students, let's have a look at the basic numerical. The length of a rod as measured in an experiment is found to be 2.48 meters, 2.46 meters, 2.49 meter, 2.49 meter. These are individual experiments, individual measurements, sorry. So this is another individual measurement. So there is an instrument they have used. What is its least count? By using this, you can tell what is its least count. As it is a single instrument with which we measure the length of the rod, the precision is same. See, after the decimal point, the number of digits are same in each and every measurement. That indicates that is the same instrument. Now, what is the least count? That's my question. The smallest measurable value from this device, from this instrument, that is 0.01. Understand? After the decimal, there are two digits. So, the least count of this is 0.01 meters. Keep it aside. It's not required for us now, but still, you should understand. When the measurement is given in this way, you should understand 0.01 meter is the least count of that instrument. Now, the individual measurements are given, so you can consider it is as x1, x2, x3, x4, x5. Okay, it is x1, x2, x3, x4 and x5, individual measurements. Find the average length. So individual lengths they have given average length, that's called your mean value. So the mean value they are asking, how you will find out? Is it x1 plus x2 plus x3 plus x4 plus x5 divided by 5? Exactly correct. So what is the values? x1, it's 2.48 plus x2, 2.46 plus x3, 2.49 plus x4, 2.49 plus x5, 2.46. all divided by how many number? 1, 2, 3, 4, 5. 5. That's called the mean. So your x mean value, if you calculate, you get it as 2.48 meters. There is no centimeter here, meter. So x mean value you get 2.48 meters. Actually, if you calculate, you will get it as 2.476 meter. So when you round off, it will give this value. So this is the general rounding of things which you keep on learning from your lower classes. But in your first PUC, in the same chapter itself, most probably in the next class we will be discussing about rounding of the digits. So there you will understand what are the specific rules while doing the rounding of the numbers. Right now, just use the basic rounding of things. Now, x mean value we have got. Next one, find the average length is done. Now, absolute error. There is an absolute error in each and every measurement, and the mean absolute error also you can find out. First find out, let me see the absolute error in each and every measurement. Delta x1 is equal to mod x1 minus x mean. What is that? x1 mod x1. What is x1? First value 2.48 minus x mean. X mean is also 2.48. I can say it is 0.00 meter. Alright. Clear? So this is the first absolute error in the first measurement. In the second measurement, absolute error x2 minus x mean will be equal to mod what is the second measurement? 2.46 minus 2.48. So x2 is 2.46, alright, minus x mean is 2.48. So what is the answer here? Actually, this is lesser than this. You get minus 0.02 meter, but as there is a modulus is present, we get positive. That's it. So delta x3, you can find x3 minus x mean. What is that? x3, 1, 2, 3, x3. It's 2.49 minus 2.48. So can I say it is plus 0.01 meter? Delta x4, which is equal to x4 minus x mean, which is equal to x4, 2.49 minus 2.48, it is also plus 0.01 meter. Delta x5 is equal to x5 minus x mean. I hope now you are understanding what exactly meant by the absolute error in individual measurement and mean absolute error. Individual measurements we are finding. So x5, what is the fifth measurement? 2.46 minus 2.48, it's minus 0.02, and as there is a modulus present, it will be plus 0.02. Alright. Now, mean absolute error, okay, fine. So delta x mean, that is mean absolute error, will be mod delta x1 plus mod delta x2, so on, mod delta x5 divided by 5. What is that? 0.00, 0.00 meters plus 0.02 meters plus 0.01 meter plus 0.01 meter plus 0.02 meter divided by 5, right? So your delta x mean value will be equal to, what is that? 0.00. It's 2, 3, 4, 5, 6. 0.06 meters divided by 5. Right? So when you solve this, you get an answer very close to 0.01 meter. Close to, including the round off. Again I am telling you, right? So 0.01 meters you get, which is mean absolute error. So We have found average length and the mean absolute error. And the percentage error also you can find out. To find the see, anyway, the other question I had given you for the classwork, and we can utilize this now. So, here, in this part I am writing continuation. Final value. After finding mean absolute error, you should immediately try to recollect the final value of x is equal to x mean plus or minus delta x mean. What is your final value here? X mean. What is x mean? Where is x mean? See here. So it's 2.48 meters plus or minus delta x mean is 0.01. Okay, 0.01 meter. This is the one. Alright. Now from here, tell me the relative error, my dear students. Relative error. What is the relative error? Did you remember? Could you recollect the relative error? Relative error is the mean absolute error by mean value. So, for your better understanding, I am writing once again delta x mean by x mean. So, delta x mean 0.01 by x mean 2.48. So, you get it approximately 0.004. Look at here. 0.004. Okay, if you want you can calculate it. Relative error is done. So the question is not about relative error, the question is about percentage error. And it's so simple, the percentage error is equal to relative error into 100. So simple. What is your relative error? 0.004 into 100. So I can say it is 0.4 percentage. That is called the percentage error. Alright? Clear? In this way, the numericals will be asked. Right? So, majority of the cases, these numericals will never be asked in the entrance point of view. You may get such kind of numericals in your unit test or monthly test, but not in the final exam. Okay? So, but still, so we have to practice. When you are confident about these small topics and which are unimportant topics, and automatically the practice will develop and you will be focused on important topics even. So now you can see the classwork. Just pause the video, read this question carefully and try solving this and send me your WhatsApp images as early as possible. Right before that, please note this and neatly understand this question, then you can solve this easily. In an experiment, the values of refractive index of glass, they have represented with the symbol N, small n. Refractive index of glass were found to be 1.54, 1.53, 1.44, 1.54, 1.56 and 1.45. So like this they have given. Calculate. Mean value of refractive index, you know. Mean. Here it's not x mean, it's n mean. N1 plus N2 plus N3 so on by number of measurements. Absolute error in each measurement, you know the absolute error, it's the difference between individual value and the mean value. Mean absolute error. The sum of all the absolute errors in individual measurements divided by total number of individual measurements. Relative error. You know, delta x mean by x mean, absolute mean absolute error by mean value, percentage error, relative error into 100. So find out and send me the answer immediately. My dear students, let's move on to the another topic. See, error basics we have learned. Different type of errors also we have learned. Now, the topic is, see, forget about this part, whatever I had written already. We'll come to that point. So the topic is combination or propagation. of errors. What is that? Combination or propagation of errors. What is meant by the propagation of the error? For example, let's take a physical quantity A. A is a physical quantity. So simple. A is a physical quantity. Any physical quantity we can write in this way. A mean plus or minus delta A mean. In most of the cases, we'll simply write any physical quantity like A plus or minus delta A. Any physical quantity will be representing in this way, A plus or minus delta A. When the error is involved in it, we will be representing any physical quantity in this form, A plus or minus delta A, X plus or minus delta X. Okay? In the same way, there is a physical quantity called B. It is also having error with it. So the final physical quantity B can be written as B plus or minus delta B. When I want to add these two physical quantities, when I want to subtract these two physical quantities, when I want to multiply it, when I want to divide them, the error also will be present in the final value. For example, if I want to add it, A plus B, you will get one value, right? In that value also the error will propagate. That is called propagation of error. Error will be moved from these quantities to the final value also. Clear? Understand? So there is a length is measured for this small rod. The length is measured for this small rod also. When I want to add these two, there is an error involved in this measurement, there is an error involved in this measurement also. When I want to add these two, what happens? The final length you get it. In that final length also errors will propagate. The combination of errors, that is called the combination of error or propagation of error. So let's discuss about how the errors will propagate in addition or subtraction. In addition or a subtraction, how the errors will be propagate. Let us discuss. Let's take the Z is the final value when I add two physical quantities called A and B. There is an error involved in the final measurement, that is Z plus or minus delta Z. There is an error involved in first physical quantity A, that its final value can be written as A plus or minus delta A plus B. There is an error involved in this B, that is B plus or minus delta. Alright. Z plus or minus delta Z, which is equal to this A and plus B I can write here. This A plus B I can write here. And remaining plus or minus delta A plus or minus delta B we are writing here. Right? Our concentration is on the maximum possible error in Z. That means the final value. Z plus delta Z, we are talking about maximum only. That is why negative is removed. Is equal to A plus B plus delta A plus delta B. Carefully see. Carefully look at the situation. Z value is what? A plus B. That means the Z is nothing but the addition of the true values. The Z is nothing but the addition of the true values. Z is equal to A plus or minus B delta A plus B plus or minus delta B. When we are finding A plus B, the true values need to be added. Then errors also need to be added, you see here. Understand? When we are finding A plus B, their true values need to be added first. Then directly, the true values directly to be added and errors also directly to be added. Delta A plus delta B. So when we solve some examples, you will understand it carefully. Right? We'll do that. So finally, what is this delta z? Delta z, can I write like this? Delta a plus delta b? Yes, delta z is equal to delta a plus delta b. So when we are adding two physical quantities, see, two similar physical quantities only will add. Will not add two different physical quantities. Mass and length will not be added, cannot be added. Understand? The mass of this is 5 grams. The length of this is 14.0 centimeters. You cannot add these two. So when we are adding two physical quantities, the errors also will be added. Now, what is this error? What is this error? This is the absolute error. Okay, this is absolute error. Delta, absolute error. Now, let's talk about the subtraction. So this is equation 1. Subtraction. Z is equal to A minus B. Equation 2. Okay. So your equation number 2. So here I can write Z plus R minus delta Z is equal to A plus R minus delta A. See, in this there is a final value Z plus R minus delta Z. A also will be having final value, that's A plus R minus delta A minus, right, carefully see, minus B plus R minus delta B. Now this I am writing, carefully see, Z plus R minus delta Z is equal to A plus R minus delta A minus B. So minus is multiplied here, minus into plus, it's minus. Minus into minus, it's plus delta B. Z plus or minus delta Z is equal to this A minus B. Okay, this is A, this is B. A minus B and plus or minus delta A minus or plus delta B. No confusions. No, where you'll understand, you will learn in this way in detail. Now, once again, what we need, maximum permissible error. The maximum permissible error in Z we need. So then Z plus delta Z, because negative we don't want, we need the maximum error possible in the Z, which is equal to A. This minus you cannot do that, you cannot do anything here. Understand? So when plus or minus is there, we consider plus. When only minus is there, you cannot do anything. Only it is A minus B. Here plus or minus is there, right? Let's consider plus delta A. Here minus or plus is there, we can consider plus delta B. Alright. So now here also the same thing. When we are subtracting two physical quantities, their true values need to be subtracted directly and errors need to be added. That is important thing. When we are adding two physical quantities, their true values need to be added directly and errors also need to be added. When we are subtracting, their true values need to be subtracted but errors need to be added. Okay. So keen observation is required in this case. So here what I can write, so this is Z is equal to A minus B. Already it is given. Z is E minus A minus B. And our focus is on delta Z is equal to delta A plus delta B. Okay, clear? Carefully go through the two cases here. In addition of two physical quantities, the errors we have added, their absolute errors we have added. In subtraction of two physical quantities also, their absolute errors are added. Alright, my dear students, I hope you are understanding. Let's look at the basic numerical of this. If L is given as, maybe L may be the length, B may be the breadth. If L is given 2.06 centimeters plus or minus 0.02 centimeter and B is given 1.11 centimeters plus 0.03 centimeters. When L plus B, simple, when these two physical quantities are added, see, L plus B, when these two physical quantities are added, what to be done? The mean values need to be added directly. So that is 3.17 centimeters plus or minus errors. What about errors? Errors need to be added or subtracted. Tell me, when we are adding, their errors also need to be added. So what is this? How the error can be added here? 0.05 centimeters. Clear? Sure? Did you understand? Now, L minus B, when we are subtracting two physical quantities, so the true values need to be subtracted as it is. Alright, true values need to be subtracted as it is. How we can do that? So this will be 2.06 minus 1.11. It is 5 here, 6 minus 1, it's 5 here. And it is 10 minus 1, it's 9. 1 minus 1, it's 0.95. So when we are subtracting, the true values directly need to be subtracted. It is 0.95 centimeters plus or minus. What about the errors now? Tell me. In addition or subtraction, errors need to be added in the final answer. So here also errors need to be added. 0.02 plus 0.03, it's 0.05 centimeters. Again, I am telling you, in addition, the true values directly need to be added. In subtraction, true values directly need to be subtracted. But in both the cases, the errors need to be added. You can see 0.02 plus 0.03, 0.05. 0.02 plus 0.03, 0.05. I hope you got the situation here. See this. L value is given. What is 3L? Directly multiply R. What exactly meant by 3L? L plus L plus L. When we are adding directly, the true values need to be added. Plus or minus. Errors need to be added here, here, here. Text me the answer. What's up? Here also the same. You do this and send me. L1 they have mentioned, L2 they have mentioned. You need L1 plus 2L2. What is the answer? L1 plus 2L2 according to the errors, combination of errors or propagation of errors. You need to send me now. In the next class, what we are going to discuss is how the combination of propagation of error will be when we are multiplying two physical quantities and dividing two physical quantities. Later, we'll discuss some more topics along with the very important numericals. All the very best for your assignment. Thank you so much.